All right, Dr. Gourley, thank you so much for talking to me today about this. NSSL has some great projects going on. I want to cover all of them, but let's start with this one with you because this is pretty cool. And it's also really relevant right now because wildfires have been just, it feels like very prevalent in the past year in our forecasting. So let's talk. Can you explain to me, first of all, because I think a lot of people don't understand debris flows and the hazards that come after a wildfire. So can you explain what that is?
Sure, I can. So after a wildfire, what it does to the landscape is quite naturally is it burns a lot of the vegetation. And what that does, hydrologically speaking, is introduces a kind of a shock to the system in multiple ways. So first of all, just the removal of the vegetation. So that means that there's going to be less uptake. There's no more vegetation that's going to capture that incoming water and use that for energy. So that's number one. So you're going to have a little bit more volume of water that's going to be entering the system. And then number two, the vegetation also acts to slow down the water. So if you do have surface water that's moving over the land surface, then having more vegetation there will help slow it down a little bit. So it's not just moving at such a high velocity. And also the roots of the vegetation do a good job of like holding down and stabilizing the soils. So there are multiple impacts that are going to affect the hydrology. And then when we get to the soils, we've probably heard the term like hydrophobic, like scared of water. And basically what happens in that situation is if the fire burns hot enough, then it's going to vaporize some of the kind of the oily material that you have on needles, coniferous trees. And so it vaporizes that material. And then what it does is it condenses down on something cool, which is going to be the soils. And so basically, you've taken that hydrophobic material and put it on the soils. So now the soils are not as capable as acting as a normal buffer, meaning not as much infiltration. So when that water hits the soils, it's going to transfer to runoff almost immediately. So those are basically the three different impacts you're going to have is a little bit higher volume of water is going to translate into runoff. That's number one. Number two, the speed's going to be a little bit higher because you've got less vegetation. And then number three would be less root structure holding down the soils. And so you can mobilize them more. And that's going to be ultimately what's going to trigger a debris flow. So on an initiation kind of zone where you have heavy rainfall, you're going to get those sediments to move, and then that's going to cascade as you go downhill.
Are there parts of the country that are more at risk than others? I mean, the obvious thought is places where there's mountainous terrain, but is that the obvious? And then there's some other less obvious?
Yeah, it's usually in terms of big debris flows, those are usually going to be in the more mountainous areas. But I should mention that after a wildfire, there's really a continuum, a spectrum. Just like in Mother Nature, we have a lot of these situations, and so you have other impacts like flash flooding is a big one. You don't necessarily have to have a full blown debris flow for it to be damaging. We have flash floods that occur quite often that can cover the roads and cause fatalities, and they can be very, very problematic, but they don't necessarily fit in the category of a full-blown debris flow. So there's probably a continuum when these occur of there being a debris flow up in the highest headwaters that then translates down to more of a flash flood and a sediment laden, this kind of muddy flows that it looks kind of like chocolate milk almost, and that's what is going to be occurring further downstream. You can also have alterations in non-mountainous terrain, and grass fires that occur in the plains and things like that. They don't tend to have as big of an impact as they do in the mountains, and that's mainly because of the topography and the speed at which those events tend to occur. So they tend to be more limited to mountainous regions.
Is there a timeline after the wildfire where this is most likely to occur, or is there like a time where it's no longer going to be an issue after the wildfire? Like, say if we're looking at the New Jersey wildfire right now, how soon afterwards do you start looking at that as an impact?
Right. In terms of the start time of the hazard, I mean, it's almost immediate. I mean, that's happened in let's see, the Thomas Fire. There have been a number of instances in California where the fire was not yet contained, and yet rain moved over, and at the time, most or some were viewing it as really welcome rain. It's finally going to put out the fire. We can move on with our lives. The air quality is going to improve. this hazard is finally going to go away, but it actually triggered a deadly debris flow that was more deadly than the fire itself when the fire was still active. So that gives you
Wow.
an idea on the start time. In terms of the end time, there's no real specific time, and it depends on climatic factors. How quickly does it recover? So if it starts raining a lot, yeah, I mean, you're going to have some impacts like in that first year. The first couple years are going to be, really active, and then things are going to slow down in the few years that follow. But it really depends on, if you have an extended drought after the fire, then it can go decade or longer. It depends on how quickly that things recover, and that depends on climatic factors really. But generally the rule of thumb is like right from when the fire has begun and is near containment to about 5 years. That's if I were to give a general rule of thumb, with most of the action occurring in the first couple or 3 years.
Does this occur with prescribed fires as well, or is it mostly like these uncontained wildfires?
Yeah, I would say mostly is going to be in the uncontrolled fires. They tend to be bigger in areas that are steeper. That are, the a prescribed fire often don't cover quite the scale at which an uncontrolled fire does. So that's probably the bigger difference there. And there could be some differences in the intensity of the wildfire too. In the prescribed, they tend to want to control some of the understory and the shrubbery and some of that, whereas when we get into the uncontrolled fire, then you're having fire up in the crowns of the trees, and it can really take off and get away from you.
Okay, so enter NSSL with some new tools, actually tools used for other purposes that are now being used for this. If there's one thing you guys love to do at NSSL is these multi-purpose tools and acronyms. So I'm curious, first of all, if this has an acronym, a cool acronym, and then also tell me about how these mobile radars are being utilized to help this issue.
Yeah, so the key factor in observing and witnessing and ultimately forecasting these events is getting the rainfall right, because they're triggered by rainfall rates, and having those details, the accuracy, the spatial resolution, and temporal frequency of updates. These are all critical factors, and it challenges our conventional observing systems, primarily NexRad network. As much as we love it and incorporate those data into the multi-radar multi-sensor system for producing a number of products, including rainfall rates. A lot of times we just don't get the coverage from the NexRad, particularly in mountainous terrain, and that's because the mountains basically block some of the low-level coverages that we would want to enjoy with that. And because of that, then it becomes beneficial to deploy a mobile weather radar in closer proximity to the wildfire where it's been burned. And so what we've used quite a bit is NOAA's X-band polarimetric radar, or NOXP for short. And so this is a radar that's used for many purposes. It's probably been received a lot more attention for, chasing severe thunderstorms in the plains and tornadoes and that kind of thing. But in our case, we use it during the off season when it's not spring. So a lot of times in the summer or even during the winter in California, then we'll move it out there close, within, let's say, 30 kilometers of a burn area, and then park it and then leave it for weeks or even months at a time. And then we go and operate during events. And the advantage that we get with that is, first of all, is it's a lot different than storm chasing, because we know where the target is, right? It's where the burn area is, and with local, state, and government partners, they've mapped out the burn severity and have a pretty good idea where the most vulnerable areas are. And so that's kind of where we target it. And then we go there, and then we basically, instead of chasing storms, we set up shop and wait for the storms to come to us. And in my experience, it doesn't take long to witness a flash flood or a debris flow event after one of these. And so the biggest advantage with the mobile radar is that we have total control over the characteristics of the scanning, the pulse characteristics, and most importantly, we're in close proximity to the area. And so we can resolve the rainfall down to pixel resolution, getting down to 100 meters or even less. And that's, in comparison to what we get out of MRMS, it's about a kilometer. So you're getting, really refining and seeing the spatial details within these tiny basins that you really need. And so with accurate rainfall rates, that's step one in order to getting towards the ultimate goal of forecasting these in advance.
Okay, so you took this for a test drive, right? Where did you see it successful? Can you tell me about the kind of what you've done working on it so far?
Yes. So we set up what we called a post-fire hydrometeorological observatory. And this was in partnership with the USGS and out of Denver, Colorado and Colorado Springs, as well as the state of Colorado. And then what we did is we set up a number of instruments, many that were on the fire itself. So this included a game trail camera near the instrumentation, tipping bucket, kind of conventional rain gauges. And then we also had soil moisture sensors, and then these other sensors that most may not be familiar with, but they're non-contact radars. And we basically position them above the streams that we think are most vulnerable to flash flooding and debris flows. And they employ two radars. One of them is a Doppler velocity radar that's looking down at the water surface, and the other one is a stage radar. And so what they're able to tell you is like how quickly is the stage or is that river rising, and also what is the speed of the water. And so we had those set up on multiple streams that we had mapped out as being vulnerable, as well as all the other instrumentation. And then the NOXP radar was about 30 kilometers parked away in a state park. So we had all of these instruments active, and I should also mention that we had a real-time component to all of these instruments, so that they had the rain gauges and the non-contact stream radars had alert levels set to them. So if certain thresholds were exceeded, then the local emergency management official, the mayor, the local emergency responders, et cetera, would receive a text that said, hey, the stream has risen, 3 feet or whatever it was in the last 30 minutes. And just take note. So yeah, we had, and then also the mobile radar data were made available to the local authorities, including the local National Weather Service office here in Pueblo, Colorado.
Cool. Yeah, I was just going to ask, and then how does that information get to the public? But so the National Weather Service gets this information.
That's right. Yeah. So it basically goes into their suite of tools as an addendum. And then we follow the normal chain of command in terms of providing alerts to the public. And in this case, I should mention that they had a really neat playbook, if you will, that was developed by the Colorado Department of Transportation. And it basically dictated different levels of action that would be taken given flash flood advisories and warnings, even separated the burn area into a northern part and a southern part. And so there were many more assets on the southern part. And so they had basically a playbook, a flash flood warning issued on the southern part of the basin. Troopers would go out and shut off certain highways, Levita Pass, and people would alert. There's like an RV community that was living right next to the stream that were mainly tourists, coming out of Texas and Oklahoma, where I'm from, that may not even be aware that there was a fire up there and that they were in a vulnerable location. And then you can imagine packing up and getting an RV out of there when you're a senior citizen in short time periods. Quite a daunting task. So they had a number of vulnerabilities, and but they had this playbook to go by, and it looked quite effective from my perspective.
Cool. Okay. And then also, I read about drones being useful in this respect as well. Are you involved in that? Can you tell me anything about that?
Yes, so we received some funding to purchase some UASs, drones, and then equip them with a number of instruments, including some of the obvious things, video and camera, things like that. But also we have the ability to map out the terrain with the drone. So what we can do is fly over and basically get a very high resolution digital elevation model. So we would want to do this kind of mapping mission after the fire and then before the debris flow. And so once we have that very detailed map of the terrain, then we would wait for a debris flow to perhaps occur, which is going to move a lot of sediment and debris and boulders and everything downstream. And then we run our mapping mission again. And then we can do kind of a difference map on those digital elevation maps and then see what it looks like. Where were the source regions of the sediment, and then where did they end up? And then you can even do things like estimate the volume and the mass and see where it all went. So that's pretty exciting. In addition to that, we'll have a hyperspectral camera that's been purchased, that's been mounted to the UAS. And with that, we can get a lot of information about the vegetation health and see if it's starting to recover. And then look at thermal IR we would have on there as well. So we can even see the temperature of the water of the streams and see what that's looking like. And generally, you get it, the water cools down when it's moving more quickly. And so there's just a whole wide array of things that we can look at from the air that we haven't explored in the past. So we're really excited just to fly some of these missions and then collect all the data we can and see what the data shows us as well.
So it seems like prediction, studying prediction, getting the data is kind of step one, but is there ever a process down the road where prevention comes into play? Is there ever anything you can do to prevent a debris flow post wildfire or flash flood post wildfire?
Yes, it's not my specialty, but I have been aware of many activities that take place typically by the local citizen groups and folks that organize that know how to do this. And so there are things that they can do in the burn area itself, like clearing debris out of the channels would be one thing. And then they do some planting and seeding and do things like that to try to encourage regrowth. Number of mitigation strategies. And they also, if you're in an area, I've seen this in Waldo Canyon in near Colorado Springs, Colorado, where they had an issue with debris that was then being pushed out onto the highway, and a lot of tourists going through there. So a lot of folks unaware of the dangers ahead, and so they can actually physically put this fencing up, if you will, that'll capture the debris whenever it goes by, and so that has some effect. So you can do certain things that are in the field itself on the landscape that'll help mitigate them a little bit. But I think still the biggest thing that needs to be done is improving the forecast product and making the public aware so that people are not in harm's way and can do things. If you're camping, you would want to be moving to higher ground. And then if you're traveling nearby, then you would probably want to alter those activities and stay away or just not travel at all.
Gotcha. Any future projects coming up with this? Where will you be studying this in the future?
Well, we kind of wait and see. We will, we saw what happened in LA, so there could be some need to take the mobile radars out there. And I should mention that we're in the process. We're under contract as we speak to upgrade the mobile radars. So we have our old workhorses down in the bay, and it's probably just going to gather some rust. As much as I enjoyed using it, I'm also kind of happy to move on to some new instrumentation. So those are under contract at the moment. There'll be some major upgrades to these radars. There'll be 3 in total, 2 X-band, 1 C-band radar. And they'll have a lot of new capabilities, and I'm really thrilled about that's going to improve our data collection in many aspects. So that's probably the number one. Those will be ready in mid-September. So we'll probably exercise them as much as we can for at least a couple months, and then there's a chance that we'll have them ready to deploy in probably January timeframe. So that could get us ready for the atmospheric river season in the West Coast. Could focus on somewhere in LA, Southern California area, or new burn scars or areas that we might go as well.
Cool. How do they compare with the Doppler on wheels?
NOXP comes from that same. I mean, they're basically clones. A lot of them, they have their little differences, but it all comes from the same developers. Back in the late '90s or so, whenever they were building those.
Gotcha. Who's coming up with these innovative ways of using severe weather tools for other purposes at NSSL? Is there just a room where you guys all sit together and try to get innovative with all of these different tools?
Well, it's kind of a tricky question because in my mind, it wasn't all that outlandish. I kind of thought they were to be used for hydrometeorological purposes, because it's very well
I mean,
suited.
you're a hydrologist, right? So that's where your mind
Exactly.
goes.
So to me, to have a radar nearby a burn area and to be able to observe the details in the rainfall, and we've had some studies that have been just recently published where we can compare what we get from NOXP to MRMS, and I mean the spatial resolution is just stunning. The gradients that we can capture within a tiny little basin that's been burned, and sometimes MRMS is only capturing like 2 or 3 pixels in there, and then you look at NOXP and it's just this beautiful depiction of the rainfall and the gradients that it captures. To me, it just makes all the sense in the world. So if anything, they're repurposing a hydrometeorological radar to chase tornadoes is the way I look at it.
JJ, is there anything else you want to add about this project or warning or advice you want to give to the public when it comes to this hazard?
Sure. I think that there tends to be an issue with public perception of a sense of relief whenever the fire is contained and it's out. And I know it can be stressful living near, an active fire and the air quality is bad. You got your bags packed, you're ready, you probably evacuated a few times already and you're looking at the wind forecast constantly. And it's a real drag to have that nearby and constantly looming. But bear in mind that the post wildfire hazards can be as deadly or more deadly than the fire itself in some cases. So don't let your guard down. Be aware that this can be, and it doesn't take a lot of rain. That's been the biggest shocker to me. I live here in the South Central Plains, where it's not unusual for us to get 6 to 8 inches of rainfall with a given flash flooding event. I mean, that's a lot of rain. But I've been out there in the West and they're triggered. I've seen flash floods that are triggered by 1 inch of rain or less. I mean, it's just a really common thunderstorm, a mountain thunderstorm where I can almost see the sunset through the shafts of rain. So it's not that intense from my perspective, but that's enough to trigger debris flow. So don't let your guard down there. A lot of times there aren't the kind of atmospheric clues that we get with other severe weather where it's barking and screaming at you. This is a dangerous situation. Take cover. Usually you have all that. But with these debris flow events, you oftentimes don't, and they sneak up on you and catch you off guard. So I think that's how a lot of these tragedies occur.
Gotcha. All right. Well, that's all I have. Thank you so much for coming on and talking about this today. It's really important to get the information out to the public.
My pleasure. Thanks for having me on. I appreciate it.